Yeah, but how's it? Alright, let's jump into quadratic inequalities. First things first, you're going to want to get standard form. So that will entail moving the 8 over so that everything is kind of equal to 0 in a sense. Remember when you move the 8 over, it changes sign, so now it's negative 8. And then I have a little trinomial on my hands over there. So I'm going to factorize accordingly. I'm going to look at the factors of 8 that will add or subtract to give me that 2 in the middle. So if I think of factors of 8, 2 times 4 comes to mind. And can I add or subtract those? I'm thinking if I say plus 4 minus 2, that will give me that 2 in the middle. So we can form our brackets from there. I like to sort of write the brackets as empty shells, just so it gets me in the hang of the procedure. And then we have x's in front. We've got an x minus 2, x plus 4. Those come from the numbers above 8 over there, which I do highlight over here. So the minus 2 and the plus 4 come from those two little guys. Alright, once that's out the way, we're going to jump into our critical values, which we use an acronym CVs to write, so that we don't write critical values every time, we just write CVs. Okay, so with your CVs, how you get them is you equate each factor to 0. So I'm going to sort of expand upon that explanation quickly. So there's factor 1. And there is factor 2. So I make each factor equal to 0. I'm going to illustrate it with the first one. So x minus 2 equals 0. Take the 2 over and we get x equals 2. And that's how I get my CVs. So in a similar fashion, if I had to do the factor 2, it will just be the opposite sign. X equals minus 4. From there, we're going to sketch our parabola. When we sketch our parabola, we always put the lower critical value on the left and the higher one on the right. So through alliteration, I remember that, lower on left. And now we want the portions of the parabola that are bigger than 0. So it's the part of the parabola, or the parts of the parabola, that are above the number line. So I've shaded them over there to illustrate it. And then critical values, lower on the left, higher on the right. And from there, I can write down my two solutions. So x should be less than negative 4, or x should be greater than 2. Alrighty, example 2 features the highest common factor. Okay, we're going to stick to our guns. Same procedure, standard form. So we're going to move the 4x over. So we've got x squared minus 4x greater than or equal to 0. Now I've got to factorize, and this particular factorization is HCF. So I'm going to remove an x from both terms. Once I remove an x from the first term, there's only an x left over. Once I remove it from the second term, there's a minus 4 left over, and that's still greater than or equal to 0. Next up, we're going to do our critical values, and I've underlined our two factors in this case. The first factor is x. The second factor is x minus 4. So from there, our critical values, we equate each factor to 0. So the first one is just 0. And then the second one, if you take the 4 over, it becomes positive 4. Next up, as per usual, I'm going to sketch my parabola. And once I sketch my parabola, I'm going to have a look at the inequality symbol. And I can see that it must be greater than or equal to 0. So once again, I'm going to shade the outskirts of the parabola. And then I'm going to plot my critical values lower on the left and the higher one on the right. And from there, I can form my solution. X should be less than 0. Or x should be greater than 4. Alrighty, next up is dots, the difference of two squares. So, a standard form, Chanabin, move that 9 over so that everything is equal to 0. Okay, inequality sign must point in the same direction. Nothing changes over there. Now, when I apply dots, you've got to square root the terms individually. So I'm going to do my shell of brackets, and then I'm going to square root each one. So if I square root 4, it gives me 2. If I square root x squared, it's just x. So the square root of 4x squared is 2x. And I chuck that in front of both brackets. Now the same order must exist. So if 4x squared comes first, the squared root must come first in the brackets. And then the brackets will nearly be identical, but one of them must be a plus and the other one must be a minus. From there we get our critical values. There's factor 1 and there is factor 2. So just to illustrate how you get your critical values from that, I'm going to show it on the side here. So you make factor 1 equals 0, take 3 over and it becomes negative 3. Divide both sides by 2 and you get x equals negative 3 over 2. So if we had to do it for the other one, we'll get the same thing just with the opposite sign. So our critical values are x equals minus 3 over 2 or x equals positive 3 over 2. Once those are out the way, as per usual, we are going to draw our parabola. So with a parabola, you always want the lower one on the left and the higher one on the right. And we can see here, we want to know where this thing is below 0 or equal to 0. So now I shade the portion of the parabola underneath the number line. So that will change the structure of my answer a little bit. Now x is going to be in between those numbers. So how to write that up? You put x in the middle. Both the inequality symbols will point to the left. That's how you express x is in between two numbers. And then I'll just chuck the lower one on the left, higher one on the right, and presto mundo, we are done. One more little note here, all your inequality symbols must match. So if you have an equals to sign, your answer must have an equals to sign. And if you don't have an equals to sign, your answer must not have the equals to sign. Alright, example 4 is going to feature the use of a new rule. If I times or divide by a negative, then the inequality will point in the opposite direction. So, you know the drill by now. First things first, standard form. So I move those two terms over. Now, you might think it's easier to move the 12 over, but I always like having the inequality on the right, so that we read it from left to right like in English. And if the inequality was on the left, then we'd have to read from right to left like Arabic. So it makes your life a bit easier. So to get rid of that negative in front of x squared, I'm going to divide everything by negative 1. So everything will become the opposite sign of what it previously used to. And we can see the inequality changes direction. That is a big rule with inequalities. You can see how it was pointing left and now it's pointing right. And it's that rule on the right that I've highlighted over there. Right, next thing's up. We're going to factorize the trinomial. So, with the trinomial, I'm going to need to get the factors of 12 that give me that negative 1 in the middle. So, let's get our brackets set up in the meantime. And let's go find our factors. Okay. So we have a look at the number in the middle, the negative 1. And now I'm going to have a look at the factors of 12. So 3 times 4 comes to mind. So how can I add or subtract those to get negative 1? Perhaps if I say plus 3 minus 4, that will give me the negative 1. So those are going straight in my brackets, x plus 3. And in my second bracket, x minus 4. That will allow me to get my critical values. My first critical value will be x equals negative 3. Remember, it's the opposite sign. And my second critical value will be x equals positive 4. Next up, we're going to sketch the parabola as always, my friends. So, once we draw the parabola, we're going to have a look at what inequality we are dealing with. So, we're dealing with the greater than 0 inequality. So, as we've seen quite a lot in this video, we're going to shade the outskirts of the parabola. Once we shade the outskirts of the parabola, we can plot our CVs, lower on the left, higher on the right, and finally we can form our solution. So our first solution will be x is smaller or equal to -3, and our second solution will be x is bigger than or equal to 4. Okay, next up is the old foiler Ruski. Those brackets are a pain. Now, I'm going to foil them, and you only foil them when there's a number on the right. We'll see what happens if there's 0 on the right in the next question. So I'm going to foil. At the same time, I'm going to bring the -5 over. So first 2 is x squared, outer 2 is plus 4x, inner 2 is minus 2x, and then the last 2 will give me -8. Bring the 5 over, it becomes plus 5. Inequality still points in the same direction. Nothing happened over there. Next, I'm going to direct my attention towards the like terms. So I've highlighted the like terms over there in green and orange. So let's take a sec to simplify those quickly. 4 minus 2 is just positive 2. And -8 plus 5 is -3. Once we do that, we focus on factorizing. So, when we factorize, we've got to look at the factors of 3 that will give me the positive 2 in the middle. So 3 is a prime number, so it only has 2 factors, 3 and 1. So I need to add or subtract those to give me positive 2. So I'm thinking if I say plus 3 minus 1, that will work out to give me positive 2. So let's chuck those in our brackets. X minus 1 as well as x plus 3. Alright, from there we're going to plot our critical values once again. So our critical values will be x equals 1, and the other critical value will be x equals minus 3. Then we're going to draw our parabola as per usual. Okay, the parabola will definitely be a happy face as always, because we've got a positive x squared present. So when I draw the parabola, the happy face will cut through, and we have a look at the inequality that we've been given. We want to know where that parabola is bigger than 0, aka which parts of the parabola are above the number line. So it's the 2 outskirt little parts, as we've seen quite a lot. And then we plot the lower critical value on the left, higher critical value on the right, and we get our solution to be x should be smaller than -3, or x should be bigger than 1. Alright, so now we're going to be covering a classic test trap. Something that is factorized and you've got 0 on the right hand side. So they've basically done all the hard work for you. They factorized, so you jump straight to critical values. Yeah, this first critical value is a little bit tricky to get, so I think it's worth our time just to do it on the side quickly to ensure that we don't make mistakes. So I'm going to go on a bit of a side mission to get that first critical value. So I grab the contents of factor 1, make it equal to 0, bring the 2 over, it becomes positive 2, and then I divide both sides by 3, and then the 3's on the left hand side cancel with each other and they can disappear, and x equals 2 over 3 is our first critical value. So our critical values will be x equals 2 over 3 or x equals -4. Okay, and then the sketch, but we're gonna sketch the parabola. So once the parabola is sketched, we have a look at the inequality symbol. Alright, so this inequality symbol is eating the zero, which means I want to know where the parabola is less than zero, aka underneath the number line. So it's the portion underneath over there. So put the lower critical value on the left, higher critical value on the right, and we can form our solution. X must be in between those numbers and include those numbers. So we put the equals to symbols with our inequality in the answer, because it was designed that way in the question, and it's in between -4 and... Alrighty, from here on out, we are going to be tackling the tough questions. Okay, so we can see this thing's factorized. There's a 0 on the right hand side. So I jump straight to critical values. Okay, that first bracket is a bit iffy, so I'm manually going to get my critical value just to be safe. So I equate the contents to 0, move the negative x over, and I get x is equal to 3. Okay, so rock solid. That's my first critical value. So x equals 3 or x equals -4. Okay, now there's a slight twist with this parabola. If I had to FOIL the brackets, if I do the inner two terms, the minus x multiplied by x, you'll notice that gives me negative x squared. If the number in front of x squared is a negative, we're going to have a sad face parabola. So we're not going to draw a happy face. We are going to draw a sad face. So you've got to be on the lookout for that small trap. This is tested quite a lot. So I'm looking for the portions of the parabola that are bigger than 0. So the part of the parabola that's above 0 is that little hump over there that I highlighted. And we're going to put the lower critical value on the left and the higher critical value on the right, as always. And x will lie in between those numbers. It won't include them because our original inequality didn't have an equals to sign. And then we are done with this question. Alrighty, welcome to the perfect trinomials, the confusing ones. Okay, stock standard procedure, standard form, boss. Let's get that -1 over. So once we move the -1 over, it's going to turn into +1. And we've got our standard form, so we're on to factorization. So this is indeed a trinomial. So I've got to use the factors of 1 to give me that 2 in the middle. Luckily 1 only has 2 factors, 1 and 1. So I need to add or subtract those to get +2. So if I just say +1 + 1, that gives me the +2 that I'm looking for. So my two brackets are identical, which will mean that I'm only going to get one critical value. Now there's no need to write it twice, you only have to write it once. So my critical value is x equals -1. Now in the case where this happens, the turning point of your parabola sits perfectly on the number line. So this is what a normal parabola looks like. If you get one critical value, you put the parabola's turning point perfectly on the number line like this. Okay, so once your parabola is on the number line, you plot your critical value. Now, I want to know where this parabola is above 0. It's actually above 0 everywhere except for one value. There's one particular x value where it equals 0, and that's at the critical value of -1. So at -1, it equals 0, so you can't include that in your answer. So basically you got to say x can be anything except for -1. So how we say that mathematically is x is an element of real numbers, semicolon, x cannot equal -1. Okay, now we have another perfect trinomial. Alright, so they were kind enough to give us this one in standard form, so I'm going to go straight to factorizing the trinomial. So I've got to use the factors of 9 to give me that positive 6 in the middle. So the factors of 9, I don't think 1 and 9 will work, so I'm going to opt to use 3 and 3 instead. So I need to add or subtract 3 and 3 to give me positive 6. So if I just say plus 3, that gives me the plus 6 in the middle. So my two brackets will be x plus 3 and x plus 3. And that gives us one critical value of x equals negative 3. So if it gives us one critical value, remember the turning point of our parabola, or as I call it, the bum of our parabola, will sit on the number line. So it's going to just touch the number line and then go back up. Okay, so once I do that, I plot my little critical value on the turning point. My critical value is at negative 3, and I want to know where this parabola is above 0. It's above 0 and equal to 0 everywhere. Everywhere. No matter what I put into x. So if that's the case, it's literally everything. X can be anything you want it to be. And how we say that mathematically? X is an element of real numbers. Alright, and our last example for the day is perfect trinomial number 3. Okay, we've got standard form. So we're going to factorize, men. Okay, so I need negative 8. So I've got to use the factors of 16. 4 times 4 comes to mind. Minus 4 will give me the minus 8 in the middle. So let's formulate our brackets from there. So x minus 4, x minus 4. Okay, so we can see we're getting one critical value, which will entail that the turning point of the parabola sits perfectly on the number line. So it's not going to go through the number line like we saw in the first 7 examples. It's going to sit perfectly on the number line like we've seen in the last 3 examples. So now, I've got my critical value at 4. My turning point is at 4. And I want to know where this parabola is less than or equal to 0. There's literally only one place where that happens. It's at 4. That's the only place that equals 0. Everywhere else, it's above 0. So your only little answer here is x equals 4.